Look at this. We open a file, write to it, then something goes wrong and we raise an error. See that close call on the last line? It never runs. The exception jumps straight past it and the file just stays open. In a script that runs once, maybe you don't notice. In anything long running, that adds up fast. I'm Kai. Think about a hotel key card, pull it from the slot, and the lights cut immediately, whether you left through the front door or climbed out the window mid-emergency. That's the guarantee we want for cleanup code. It runs no matter how the block ends, without you handwriting. Try finally every single time. And no, you don't need to know classes or decorators yet. It comes down to two small methods coming up right now. Same broken example, rewritten with. We open the file, write to it, still raise the same error, but this time the file gets closed anyway. We didn't write try, we didn't write finally, we didn't write close. That's the whole point. With promises clean up no matter what happens inside the block. Same broken example, rewritten with. We open the file, write to it, still raise the same error, but this time the file gets closed anyway. We didn't write try, we didn't write finally, we didn't write close. That's the whole point. With promises clean up no matter what happens inside the block. Watch what happens when an exception hits this block. Python doesn't skip exit, it hands the exception straight to it. Exit receives three things: the exception type, the exception value, and its traceback. Now here's the part that actually cost people time. If exit returns true, Python treats the exception as handled and swallows it completely. I did this by accident once, returned true out of habit, and spent an hour wondering why an error I knew was happening just vanished. Return false. Let's build one from scratch, so this stops feeling like magic. Enter just records the start time and return self. Exit calculates how long the block took and prints it, and we return false, so any real exception still gets raised like normal. That's the entire protocol. First piece, done. Here's the same with block from earlier, lined up against our class. The moment Python sees with timer, it calls enter. Everything inside the block runs next. The instant we leave the block, for any reason, exit runs. That's the whole mental map. With block equals enter, then your code, then exit. Writing a whole class for something this small feels heavy, and Python agrees. The context manager decorator lets you write the exact same behavior as a plain function with one yield in the middle. Same timer, 4 lines instead of a whole class. Clean. Before I reveal it, take a real guess. In that generator function, which lines do you think act as enter and which act as exit? Drop your guess in the comments before you keep watching. Here's the trick. Everything before yield is enter. Python pauses right at yield and hands control to your with block. Everything after yield, wrapped in a try finally, is exit. One function split into 2 jobs by a single word. Files are just the easiest example. The same pattern shows up anywhere you have a setup and a matching teardown, locks, database connections, temporarily changing some setting and putting it back afterward. Honestly, I think most people reach for a full class out of habit when context manager would be shorter and just as clear for a one-off case. So here's what we actually built today. We started with cleanup code that only ran if we remembered it, and we fixed that by wrapping enter and exit around your block, guaranteed no matter what happens inside. Write the class yourself when you want state and structure, or reach for context manager when a function with one yield says the same thing in fewer lines. One thing we didn't touch, Python also has async with for asynchronous setup and teardown. That's a whole other video. Some code is unreadable. This button is not subscribe. If something feels off or missing, or you want to see something new, tell me in the comments.